Hello everyone. My name is Gerrit Böhm. I'm founder and CEO of OpenCapacity. We're specializing in AI-driven capacity monitoring and forecasting for public transport. So the particular challenge that we're addressing is that there's still limited information on how busy trains and buses are, which makes it difficult for the operators to effectively match supply and demand, which leads to a suboptimal performance and also customer experience. This unmanaged supply and demand can cost the operators a substantial amount of money in penalty fees caused due to overcrowding, which is caused by delays due to inefficient boarding and lighting, but also a mismatch of rolling stock supply and passenger demand. So the way that we are addressing this is unique. Our platform is sensor agnostic, meaning that we're using existing data sources that are already available on the public transport vehicles. For example, load weight data on the air pressure suspensions, using weighing the carriages, how heavy they are, using an average human body weight to estimate how many people are on a carriage. Or, for example, video analytics, using object detections, objects being human, detecting how many or counting how many people are on a carriage. So on that lower level, on the acquisition layer, we always work with the operator to identify what sensors are available or what data sources are available. And on the next level, add the intelligence to it. We combine it with external factors such as weather, events around the stations, but also network-related events such as delays and cancellations to see what impact they have on the capacity on the vehicles. That we feed into our prediction engine to learn from the historic data and get the live updates in order to predict how busy the trains will be, or buses for that instance. We then provide this information to the operators on an analytics dashboard to historically understand how the network is utilized, monitored in real time, and also predict how the future state of capacity will be at any given station for that particular trains. The operator can also use this information provided back to the passengers, which has an impact on the service. So by telling people in advance how busy their trains will be, will shift the morning or afternoon peaks if people choose to travel early or later. So that naturally reduces the peak, which has an impact on the service. But if they can't travel early or later and they're already on the platform, people can choose where to board, which makes the boarding more efficient and reduces the dwell time. So this global market of monitoring or smart monitoring systems for public transport is very large. We focusing currently on the European market, which is estimated to be 3.2 billion, which is a substantial market. The current way of how we sell into the market is by running proof of concepts or pilots to test drive our technology, which then lead to rollouts with the particular operators. We're currently live in Stuttgart and in Munich, and working here in the UK with some operators to do the same here. Our business model is a software as a service with an initial setup for that to design the prediction engine for that particular unique network, and then add some additional features in the future once we have more capacity data to kind of combine it with ticketing and so forth to do some more analytics. We are a diverse set of team from IoT expert, big data engineers, but also AI engineers, and also have some rail domain knowledge to help us understand the market that we operate in. We are currently raising a round of 500,000. We have already 300 committed, and we are still looking for a lead investor to help us close that round. So there's 3 parties who want to co-invest, and we are looking for a lead investor. So rounded up, we are OpenCapacity. We are specializing in AI-driven capacity monitoring and forecasting. We are sensor agnostic. We utilize big data and AI to provide real-time capacity information and forecasting for public transport to enhance passenger experience, but also predominantly the performance management. Thank you very much.
Gerrit, hi.
Hi.
Thanks very much for that. Could you just draw a bit more on actually how you're drawing out the data, the product that's actually sending the data to then be analysed?
Yeah, so it depends on the type of data sources that are available. For load weight data, that comes from the air pressure suspensions to kind of weigh how heavy a carriage is, and we get the data from their onboard computer, so we kind of accessing it through the backbone. So it's either being sent directly by the operators or the rolling stock manufacturer, the OEM, to our cloud platform, where we then further add the external data to actually provide the predictions. For video analytics, we're actually installing a small hardware on the train to again plug into the backbone or into the digital video recorder directly to get a substream from the cameras to do video analytics, and then send off just the counts per carriage. So no video footage, so privacy is protected and no low bandwidth.
Thanks very much for your presentation. I was wondering if you could comment on the competition, because I certainly get information as to which carriage has spaces in at the moment when I travel.
Oh, my mic is still working. Okay, still on. So there's certain operators or certain apps are using, for example, Trainline, ask their passengers to kind of how crowded do you feel it is. So this information is good for passengers. So if they use it for telling passengers how busy a train will be, it's great because they don't need to know the absolute number. But for an operator to understand how their actual network is utilized, getting to closer to the absolute number, like 100% accurate if possible, helps them to use this information for revenue sharing, to drive their rolling stock configurations, not just having red, green, and amber. This is it's good for passengers, but not so good for operational planning. I'm not sure if I answered the question, but please.